All right, Bailey, something weird was going on with you. I kept trying to admit you and it wouldn't let me. So I finally had to not admit you and had you try to get in again, which I was hoping you would do. And we got you in here now, so we're all good. All right, so we're going to continue on. We're talking about basically finding trig functions based on degree measures or radian measures. So let's go ahead and continue on with that. So we talked about finding the sines and the cosines, and we found out that pretty much sine and cosine is always going to give you either 1/2 the square root of 2 over 2, which is about 0.707, or the square root of 3 over 2, which is 0.866. Okay, so we talked about sine and cosine. I think where we left off, we were getting ready to talk maybe a little bit about tangent. So let's go ahead and talk about that. So now here's what you're going to find for tangents. So tangent, let's go back to our SOHCAHTOA thing and that kind of stuff. Let's get something to write with here. All right, so tangent on the SOHCAHTOA thing. So we got that. So that's sine, there's cosine with the crazy looking A, and tangent, the less crazy looking A. Okay. So again, this whole idea is that we're going to have some angle here, theta. This is the opposite side. This is the adjacent side. And this is the hypotenuse. Okay. So notice here that we know the sine is the opposite over the adjacent. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Okay. So you do have a tangent button on your calculator, but let's talk about what's going to happen when you get tangent. It also turns out, in addition to tangent being the opposite over the adjacent, the tangent is also the sine over the cosine. Okay? So here's the interesting thing about that. So we know sine in terms of the SOHCAHTOA thing is the opposite over the hypotenuse. Okay? And the cosine is the adjacent over the hypotenuse. So sine over cosine is opposite over hypotenuse over adjacent over hypotenuse. So here's a useful hack for you on these. Notice in this case we have a fraction over a fraction. Notice both of the bottoms are hypotenuse, right? So that means you can cross these guys out because they will cancel when you divide. And you're left with opposite over adjacent, which is this guy right here. Okay. The reason that they're going to cancel out is, remember, when you divide a fraction by a fraction, this is really opposite over hypotenuse divided by adjacent over hypotenuse. Okay. Now, when you divide a fraction, you flip the second guy and multiply. So if we flip him over, he will become the hypotenuse over the adjacent, right? So the hypotenuse over the adjacent. And these guys would cancel, so there's your opposite over adjacent. Okay, so here's the reason I tell you all this stuff. So let's talk about these guys here. And let me go ahead and I'm going to just recopy this guy and start with a clean slate here. Duplicate that slide, break out our mega eraser. Okay, so let's clean this up a little bit. Thank you, Melanie. All right. Okay, so first things first, let's switch this guy into degree mode because it's just easier to deal with, right? So let's go ahead and do that. All right, so if we do degrees on this, this would be 7 times 180 over 3. Okay, so then we break out our calculator and we go 7 times 180 and then divided by 3. Okay, so that's 420. So this will be the tangent of 420. All right, so let's do that on our calculator. So we've got 420. We go over here, we hit the tangent, and I get 1.73 blah, blah, blah. Okay, so there's 2 answers you're going to get. Well, there'll be 3, but there'll be 2 answers you get for tangents. You know how with the sine and the cosine and that kind of stuff, we only had 3 usual answers that we would get. We would get 1/2, we would get the square root of 3 over 2, or we would get the square root of 2 over 2, right? So here's what we got here. So the tangent of 420 is the same as saying the sine of 420 divided by the cosine of 420. All right, so let's do that. All right, so we got 420. We take the sine, and we get 0.866. So that would be the square root of 3 over 2, right? And now let's do the cosine. So we do 420, and we do cosine. And that's 0.5. Okay. So 0.5 is 1/2. Now remember our useful little hack here I mentioned was that when we get one over the other and the bottom numbers are the same, we can cross those off. So now all I've got is the square root of 3 over 1, which is just the square root of 3. Okay. So the tangent of 420 equals the square root of 3. And the square root of 3 on a calculator is 1.73. 1.732 really. So that's another one to remember, is square root of 3 equals 1.732. Okay? So that's one answer you'll get. The other answer you'll get is the square root of 3 over 3. And when that happens, that would be a number where the sine would be 1/2. And the cosine would be the square root of 3 over 2. So remember, these are about the only values you can get for sine and cosine, right? 1/2 and the square root of 3 over 2. So this guy's same thing. When we cross these off, we get 1 over the square root of 3. Okay? And remember, they don't like square roots in the bottom, so we're going to multiply the top and the bottom by the square root of 3. So you get the square root of 3 here. Over here, the square root of 3 times the square root of 3 is the square root of 9, which you know that's just regular 3. Okay? So these are 2 of the 3 answers you'll get when you're taking the tangents of stuff from the unit circle. You either get the square root of 3, you'll get the square root of 3 over 3, Okay? And then to recognize that guy, let's go back to our calculator for a second. There it is. So this is the square root of 3, 0.1732. We already said that. Okay? So if we take that guy and divide him by 3, we get 0.577. So this guy on a calculator is 0.577. Okay? So when you have a tangent that's a multiple of 30, 30, 60, 90 kind of thing, right? You will get one of two answers. You'll either get the square root of 3 over 3, or you'll get just plain square root of 3. Okay? So let's talk about this guy. 405. Okay, so when they end with 5s, this is probably going to be a multiple of 45. We can figure that out on our calculator as well. If we take 405 and divide by 5, yeah. Actually, I want to divide by 45, my bad. So we clear that out. So 405 divided by 45, there we go. So that's 45 times 9. So now here's the thing. If you get something that's a multiple of 45, your answer is either 1 or -1 for tangent. Why? Because the 45-degree measures for sine is the square root of 2 over 2, and for cosine is also the square root of 2 over 2. And anything over itself is just 1. But let's check it out. So we go 405, and we do the tangent, and it's 1, as predicted. So this is saying the sine of 405 would be the square root of 2 over 2. The sine of, or excuse me, the cosine of 405 would be square root of 2 over 2. So let's check it out. So if we say 405, and then we take the sine, we get 0.707, which we know is the square root of 2. And then divide by 45, and then take the cosine, we get the same thing, and when we hit equals, we get 1. So the tangent values you will always get will be the square root of 3. Could be plus or minus depending on what quadrant you're in. Square root of 3 over 3. And again, plus or minus. Or plus or minus 1. Same values all the time. Okay? All right, I threw a lot of stuff at you. Any questions? No? Okay. So again, just if you recognize some of these values that we've been talking about, and I should probably just make a list of all of them at some point. So this guy, and then this guy is the square root of 3 over 3. Okay. And as we said, the square root of 2 over 2 is 0.707. Square root of 3 over 2 is 0.866, and obviously 1/2 is 0.5. So if you know these funky values, we can use our calculators, but give them the numbers they're looking for. Because they won't give you 1.732. They'll say, well, it's the square root of 3. Okay? So that's the kind of stuff we're going for. All right. So sine, cosine, and tangent are kind of our normal dudes. So let's talk about our weird dudes. Let's talk about them for a minute. All right, so secant, cosecant, and cotangent of each. All right, so probably going to go ahead and duplicate these screens a couple times because we're probably going to need the space. Okay, so how do we figure out secant, cosecant, and cotangent? Well, it kind of goes like this. And again, I want to show you how to do this on the calculator. So remember, secant goes with cosine. We have one code per pair, and we need to get out of the highlighter mode. That would help. So that's going to be, if I can get this thing to right, that would be fabulous. So this goes with cosine, this goes with sine, and this goes with tangent. This one kind of makes sense. Okay. So the first one here is, what is the secant of 315? Okay. So secant is really saying the same as 1 over the cosine of 315. Okay. So let's check it out. So what we can do is we can do the cosine of 315. So we'll go 315, right? Find our cosine. And there's our good buddy. Square root of 2 over 2, right? So this would be 1 over the square root of 2 over 2. Okay? Now, remember the whole bit we said before that if cosine of 315 equals the square root of 2 over 2, then the secant of 315 is just flipping that guy over. So it'd be 2 over the square root of 2. And again, you know, these guys, they don't like the square roots in the bottom. So we're going to do this bit again. Okay. So square root of 2 over the square root of 2. So if we do that, that's going to equal 2 square root of 2 over the square root of 2, and the square root of 2 is the square root of 4, but that's just 2. I've got 2 over 2, right? Those just cancel out. So the secant of 315 is the square root of 2. And that's another one it wouldn't hurt to notice on here. So another way you could do this is you could say, all right, I know that it's 1 over the cosine, right? So let's do that. So 1 over the cosine is 1 divided by the cosine. All right, so if I go 1 divided by 315, take the cosine, and then hit equals, we get 0.414, or 1.414, excuse me, which is the same as saying the square root of 2. So there it is. Okay. So now we do the same thing with the secant. So we're going to figure out the sine, right? So do the sine of 315. All right, so calculator time, where are we at here? So we do sine of 315, so let's clear it out. We go 315, do the sine, and we get negative square root of 2 over 2, right? So that means then the only difference here is if we do 1 over that, I can do that by saying raised to the minus 1 power. So I get minus square root of 1.414, which is minus the square root of 2. Okay, so secant of 315 is the square root of 2 over 2. Cosecant of 315 is negative square root of 2. And then tangent of 315. So let's do that one. So the tangents are usually easier when you get a 45-degree angle like this. So we do 315, and we do tangent, and we get -1. And 1 over -1 is still -1. So then the tangent of 315 would be -1. Okay. So again, we can work with the calculator and just recognize some of the values that we get. All right, so let's look at 750. Okay, so let's just do secant straight out. Clear it. So secant is 1 over the cosine, so 1 divided by 750, and then cosine. 0.866 equals, so this is 1.15. All right, so that's one we're not used to yet, right? So here's the thing. So this would be the secant of 750 is the same as saying 1 over the cosine of 750, right? And we figured out the cosine is 1 over the square root of 3 over 2, which again just means flip it over, right? So we've got 2 over the square root of 3. All right, so then we have to multiply top and bottom by the square root of 3 over the square root of 3. So the top will be 2 square root of 3. The bottom, square root of 3 times the square root of 3 is just regular 3. So that's your answer. So 2 square root of 3 over 3. Okay. So that's secant. So cosecant. So this time we're going to do 1 over sine of 750. Okay, so let's go ahead and do our calculator. So this one's going to be 1 divided by 750. Take the sine. That's 0.5, hit equals. Oh, that's just 2. Okay, we like that one a lot better, right? That one you can figure out in the calculator. The other one we had to do a little bit of work for. Okay, and then cotangent 750. So that's going to be 1 over the tangent, right? So we go 1 divided by 750, and then take the tangent. There's a 0.577 like we got before. And now we got 1.732. So what does that guy equal? Remember what we said 1.732 is equal to? What square root does that one work for? Square root of what? Yeah, I'll have to put a sheet together with all of these guys on them. So we just try some. Well, square root of 2 is 1.4. That's not it. So let's try square root of 3. There it is. So this is just going to be the square root of 3. So if we start recognizing these guys, it'll help. So then for this one, secant of 750 is 2 square root of 3 over 3. Cosecant was a nice one. That was 2. And this guy was the square root of 3. so let me duplicate this. We'll try a couple more. All right, so let me erase this stuff. Use a clean slate here. All right, so that's 28 and 30. We need to do 29 and 31 yet. Should probably just copy this thing again right now. Yeah, trying to get it cleaned up. There we go. All right, let's do that one more time. Okay, so let's do this guy. So we have 13 pi over 4. So first things first, let's make him degrees. So this will be 13 times 180 because pi is 180, right? Divided by 4. Okay, calculator city. Clear it out. We got 13 times 180 and then divide by 4. So that's 585. All right, so let's do our stuff here. So we've got secant. So that's going to be 1 over cosine of 585. And we don't care that these numbers are bigger than 360. With the calculator, we can still work with them. All right, so let's try that out. So we're going to go 1 divided by 585, and we're going to do the cosine. So that's going to be the square root, negative square root of 2 over 2. And then when we take and put it over, we get negative the square root of 0.414, which we figured out a little bit ago is the square root of 2. So this guy is just going to be the square root of 2. Okay? So that's secant. Cosecant, so again, this guy goes with cosine. This guy goes with sine. This guy goes with tangent. Let's just do sine, or do cosecant. So cosecant is 1 over the sine of 585. Okay. So same deal. Go over here to the calculator. And they don't usually put secants and cosecants on calculators. I don't know if they do on the fancy ones or not. But usually if you get sine, cosine, and tangent, you're doing good. So then same thing. So this is cleared out. We're going to go 1 divided by 585, and then this time we're going to take the sine. So he's negative square root of 2, because we got that 1.414 thing again. Okay, and then finally we've got the cotangent, 585, and that's just going to be 1 over the tangent of 585. So let's hit the calculator again. So clear it out. We do 1 divided by 585 and take the tangent. That's just 1. It equals, and it's still 1. So there we go. Well, those answers weren't bad. So secant of 585 is the square root of 2. Cosecant is minus the square root of 2. And find the tangent is just 1. Beautiful. All right, so let's go ahead and work on the last one. All right, so we got a negative sign. Actually, I forgot about the negative sign here, but the procedure's still the same. Okay, but we'll use the negative sign on this one. So we've got -2 times 180 over 3. So pop that in our calculator. Here he is. So we're going to go 2 negative times 180. That's -360 divided by 3 is -120. Okay. All right. So -120, what that means, remember this bit, is if we start here on the positive x-axis, -120, this would be -90 to here, and then -120 would be over in here someplace. If you go the other direction, this would be 180, and in the positive direction, it's 240. So if you go 240 degrees in the positive direction, it's the same as going 120 degrees in the negative direction. Notice 240 and 120 will add up to 360. So that's your whole thing. But we can use the negative sign. It's no big deal. So let's go ahead and do that. So again, the secant this time is -120. All right, so let's see if we get here. So there's our -120. Go ahead and do it this way this time. So we'll do cosine. So it's -0.5. And then to do 1 over, you can hit this 1 over button here, and you get 2. -2, excuse me. So he's -2. Okay, so cosecant of -120. So you can do the same thing again and clear it out. We go 120 negative. It's nice to get the 1 over button. Some calculators do, some calculators don't. Yours may vary. So this time we're going to do the sine. So that's the 0.866 thing, isn't it? And then we do the 1 over. And we get that 1.15. So the 1.15, let's go ahead and make note of that. That's going to be the square, or 2 times the square root of 3 over 3. So 2/3 the square root, that's going to be 1.15. So that's this guy. He's going to be 2 square root of 3 over 3. Okay? And just to double check ourselves on that, if we did 3 and took the square root and then took it times 2 and then divided by 3, there's that 1.15. Obviously that one had the negative sign in front of it, but that's okay. So yeah, I'll put up a list of the decimal equivalents sometime, and maybe I'll just post it on the modules. Okay, so let's do the last one then. So then we have got cotangent of -120. And we got an extra minus sign there. Hang on. Let's get rid of him. Go away. There we go. All right, so he's going to equal. What just happened there? I don't know what I just did, but I got rid of my drawing. Weird. There, it's back. Huh. That was odd. All right, what problem are we on? This isn't it. There we go. So cotangent of -120. That came back. That's fine. We don't care. All right, so let's get our calculator out. So then we'll do -120. Take the tangent. All right, so that is the square root of 3, 1.732. And then we're going to do 1 over that is 0.577. That's going to be the square root of 3 over 3. Okay? So that's your answers on that one. So yeah, what I need to do is put together a sheet of the decimal equivalents so that you guys know what we've got, and that way you can work with your calculator and everything will be fine. Any questions? Yeah, I think that'd be helpful too. Like I say, I know most of the basic ones off the top of my head. You know, the 1.55 I have to think about for a second, you know, and the 0.577. But yeah, I think that's kind of where we're at here. Let's see if we get time for one more. Yeah, we could probably knock this one out real quick. So this one says, which of the following is the tangent of 4 pi over 6? Which, by the way, is 2 pi over 3. I don't know why they didn't do it that way, but that's okay. So first thing we do is we'll take our calculator and we'll say, okay, we'll do 4 times 180 and then divided by 6. So that's 120. So they want the tangent of 120. So we go like this and we get the tangent is negative 0.732. So which answer is our guy? A, B, C, or D? Well, we know this is minus 0.5, so it's not him, right? Minus the square root of 3 over 2, that's minus 0.866. It's not him, right? And then we've got minus the square root of 3 over 3. He's going to be even smaller than this guy. I think that's the minus 0.577. So by process of elimination, it's this guy. And all you'd had to do on your calculator was the same thing. You could have said, well, let me start with the 3 and square root it. And there I get the same number. So it's A. See how that works? You just have to turn it into the answers that they like. Okay, last one. So this one says, what is sine if the cosine of theta is minus 5 over 13 as in quadrant 2? So it looks like this. So we're in quadrant 2, right? So the cosine is the adjacent over the hypotenuse. And after we've done enough of these, we know this is a 5, 12, 13 triangle. Or you could Pythagorize it and you'd still get 12. Okay? Now, since we are above the x-axis, then it's going to be a positive 12. And the hypotenuse is always positive. So then it says, well, what's the sine? Well, here's the angle we're talking about, right? So sine is the opposite over the hypotenuse. So there's your boy. Easy and peasy. Lemon and squeezy. Cool. All right, ladies, and on that happy note, I'm going to let you go. And we'll reconvene tomorrow. And we'll see you then.